Mit Pierre Lacombe hat er 2017 einen Meinungsartikel geschrieben, in dem er das vorherrschende Verständnis über den Zustand des Great Barrier Reefs in Frage gestellt hat. Im April 2016 ergriff die James Cook University Disziplinarmaßnahmen gegen Peter Reed, die in seiner Entlassung gipfelte, gegen die er klagte. Interessanterweise 2019 gewann er diese Klage und die Richter stellten damals fest, Zitat, die Universität hat das ganze Konzept der geistigen Freiheit nicht verstanden. Gut, aber jetzt fast zu früh gefreut. Im Juli 2020 gewann die James Cook University wiederum die Berufung gegen das Urteil, wogegen er wiederum Berufung eingelegt hat, die jedoch abgewiesen wurde. Die Geschichte geht noch weiter bis ins Jahr 2021, aber wir wollen heute nicht über juristische Fälle sprechen, sondern über wissenschaftliche Themen. Und deshalb, without much further ado, will ich Peter Reed seinen Vortrag hier ankündigen. Stirbt das Great Barrier Reef? Über den wahren Zustand des Great Barrier Reefs. Peter, the floor is yours.
Thank you very much. Hopefully you can see this, these slides now. So we're going to talk about the Great Barrier Reef and the true condition of the reef. Just getting a bit of feedback here. I'm not sure how to remove that. Well, essentially, let's start here, which is the most important thing, which is essentially that we're at record high coral cover. So this is a graph of coral, and we see that we're at record high. You can still see that screen, Wolfgang?
We see this.
Yeah, okay. All right, so I wrote an article about this tremendous coral cover. And what happened then was the fact checkers from Facebook swung into action. I understand they've done a similar sort of thing to Susan Crockford, and they reckon that the Great Barrier Reef has declined over the past decade, and they said that my comments were inaccurate. So if we actually look at the raw data that comes from the Australian Institute of Marine Science, what we do is we look at the three major regions of the reef. So there's the northern, the central and the southern zone, and we actually look at the coral cover. A decade ago it was high. It actually crashed, partly due to bleaching, partly due to hurricanes, but now it's completely recovered and we're more or less the same coral as that we were a decade ago. If we look at the central region, it was actually at its low a decade ago, and now it's recovered. It's swung dramatically. This low point here was due to a major hurricane mostly, but we've now got about twice as much coral as we had a decade ago. And if we look at the southern Great Barrier Reef, where again, a very large cyclone caused a lot of loss of coral, we're now 2 to 3 times more coral than we had a decade ago. So it's actually quite difficult to see how the fact checkers, claim that the reef has declined, when in fact the summary is that the northern region has got about the same, the central region has got double the amount of coral, and the southern region has got 2 to 3 times the amount of coral. So this is remarkable that these fact checkers have been able to actually use these exactly the same graphs, but claim that the reef has declined. And so it should be no surprise that we've been able to convince the world that an area the size of Germany is almost dead, when they can easily say that something that is obviously going up is going down. And obviously the problem we've got is with these phenomenally unreliable scientific institutions. Now, when it comes to climate change, it should be no surprise that, in fact, corals will do quite well in a warm climate, because if you actually plot the coral growth rate in the vertical axis versus the temperature, you can actually plot quite a reasonable relationship, which shows, as you'd expect, that corals like warm climates and they grow much faster there. So, for example, most of the corals that live on the Great Barrier Reef also live in Indonesia on the equator to the north of us here, and they grow roughly twice as fast as the corals on the southern Great Barrier Reef. So in a warming climate, whether that's anthropogenically driven or whether it's due to natural fluctuations, we should expect corals to do much better. But nevertheless, there's no doubt that on occasions very large amounts of coral dies, and you'll see pictures like this with coral that's in this case being killed by bleaching. And this will occur every few years, whether it's from a cyclone, a bleaching event, and so this gives the doomsayers a never-ending bad news. And I've been listening as a resident of North Queensland for over 50 years now. We've been hearing for 50 years how the reef has only got just a decade or so to live. And this is partly because of this huge variability. The coral crashes and then it recovers. Most of the crash is due to hurricanes or cyclones. This gives a never-ending stream of bad news. But of course the coral regrows only for another few years' time for it to crash again and all the bad news occurs. I often compare it with the legend of Prometheus, where we have this never-ending agony, where in Prometheus he was chained to a rock by Zeus, and an eagle would eat his liver out each day, and only for his liver to grow back overnight for it to be removed. Sorry, just only for it to regrow. So the agony just never ends. And in the legend of Prometheus, there was a guy called Heracles who finally unchained poor old Prometheus, and we need a Heracles to come along to free us from this agony of the supposed constant death of the Great Barrier Reef. But it's not just climate change which is supposedly killing the Great Barrier Reef, it's also agriculture. So we're told that sediment or mud from agriculture is killing the reef, nutrients are killing the reef, pesticides are killing the reef. Nutrients, by the way, that's fertilizer, dredging from shipping channels, and also fishing. And this is more examples of extremely dubious science being used to try to tell a story that really is completely wrong. Now, it turns out that I spent the best part of a career looking at mud on the Great Barrier Reef. We invented the instrumentation to do that, and we took more measurements of mud on the Great Barrier Reef than all the other groups put together. But of course we were completely ignored because it didn't fit the story. So for example, they reckon farmers are killing the reef from all the soil erosion, but when you go to a reef like this one, and if you go to this sediment, this is white coral sand, and you take a sample of that, you find that there is no land-derived sediment there at all. It has a different chemical makeup. Coral sand is calcium carbonate, and you can prove without any doubt that, well, if the mud doesn't actually get to the reef, how can it be killing the reef? It's quite remarkable. And so you've got to wonder, well, why is the water so pure on the Great Barrier Reef, and why is it that the farmers are having not much effect? Well, the main reason is the reef is a long way from the coast. It's 50 to 100 kilometres from the coast. And the pollution that might be coming down the rivers has a hard time getting out there. But also, the fact is that the reef is adjacent to the Pacific Ocean and the Coral Sea, and massive amounts of very pure water comes into the reef, and if there was any pollution, it's very rapidly removed. So, for example, this graph here shows the coast of Queensland, with the Great Barrier Reef just a little bit offshore, well, 50 to 100 kilometres offshore. The scientists say that the rivers coming in from the coast are killing the reef, but you have these massive ocean currents, rivers of salt water, which are 10 to 100,000 times as big as any river, sweeping into the reef and removing any pollutants well before they could cause any problems. But all this is ignored, you see. Now, when it comes to the Great Barrier, we are having some success at a political level, convincing people that the science institutions are utterly untrustworthy. So we had a Senate inquiry where we were able to get information, extract it from them to say that pesticides, for instance, are a low to negligible risk on the close inshore reefs, where there's about 1 to 3% of the coral, and a very low to negligible risk on the Great Barrier Reef, where there's 97% of the coral, and that the data consistently finds that the concentrations are so low that you can't even measure it even with the most sensitive scientific equipment. But yet, despite these low to negligible and very low to negligible, by the time they report it in the sort of the summary of the major Great Barrier Reef reports, the equivalent of the IPCC reports, suddenly it becomes a high risk. And we're asking the question, well, how can this possibly be true? And politicians are certainly raising their eyebrows at that. Now, it's not just the farmers. Of course, they want to pick on coal. Now, Queensland is a huge exporter of coal. It's our biggest export by a long way. And there's a very famous paper that's claiming that coal dust blowing off the ships are going 100 to 200 kilometres away and killing the reef. And it's been demonstrated it's complete rubbish, but now there's a cover-up to try to pretend this never happened. So what happened is there was a paper by this person, Kath Burns. She said coal dust reached 200 kilometres away. This was quoted in 2014 to a Senate inquiry, and they called to stop the dredging of all ports exporting coal. This would stop the coal industry in Queensland, our biggest export. The paper was quoted in the two main reports on the Great Barrier Reef, and also on a quasi-United Nations report on the reef, that coal dust was killing the reef. But there was a scientist called Simon Appi, who works for a major Australian scientific government organisation, who demonstrated that there was a small error of about 1,000 to 3,000%, and it was actually doubtful that she was even measuring coal in the first place. She was measuring polyaromatic hydrocarbons, which are naturally occurring, and they're not necessarily just come from coal. And Apti showed that the coal dust was definitely not a problem. But as you'd expect, the journal refused to retract the work, and they refused to publish Apti's commentary on this, demonstrating the errors. The institution, the Australian Institute of Marine Science, responsible for the data, has done nothing to change the record, and the main authority for the Great Barrier Reef has also done nothing. And yet this continues to be quoted in all the influential reports. So this is yet another example of utterly no commitment to the truth at the institutional level in the Great Barrier Reef, which should be no surprise to anybody at this conference. So how reliable are our science institutions? Now, there was a time, I think, where they were quite reliable, and still today there are many institutions in other areas which are highly reliable. But I don't think that is necessarily true where there's likely to be an element of ideology. It's sometimes hard to tell whether these institutions are advisors to government or whether they are bullies of government. Though I think in the case of the Great Barrier Reef, it's pretty obvious they're bullies. They're telling the government what they want to have done about the reef, and they will make up just about any rubbish and name it as science. All right, so what is without doubt true is there's some alarming quality assurance problems in science in general, and certainly for the Great Barrier Reef, and certainly for climate change. And we've got to focus on the more general problems of quality assurance in science, because it's no good just keeping on pointing out individual bits of science which are wrong. You've got to ask the question, how did that happen? In industrial quality assurance, it's one thing to fix the problem, but it's much more important to understand why the problem occurred in the first place. And that's what we have to do. We have to fix the science quality assurance problems. And of course, we've got beautiful evidence from right across science that the peer review system is completely hopeless. It has about a 50% fault rate. It's particularly acute in the environmental and social science. This is well known within the scientific community, but it's not well publicised to the man in the street. So, whereas in this conference we are probably in something of a minority as climate skeptics, not a huge minority, but maybe something of a minority when it comes to climate change, we are in the majority when it comes to whether or not there is a consensus about problems of quality assurance in science in general. All the major scientific institutions agree that peer review has got a very, very high fault rate. So, for example, the editor of the Lancet journal says this of peer review: "We know that the system of peer review is biased, unjust, unaccountable, incomplete, easily fixed, often insulting, usually ignorant, occasionally foolish, and frequently wrong," right? And why would we think that there's any less problems in the Great Barrier Reef or climate science than there is in medical science? We have John Ioannidis, who is not a climate skeptic, but he's published this incredibly famous paper, "Why Most Published Research Findings Are False." Well, if that's true in medicine, why isn't it not also true in climate science? And we've got to use the fact that there is a major scandal which is breaking right around the world over the last decade, demonstrating we have problems in science in general. So it started with the drug companies quite a few years ago. When drug companies take promising maybe university research and they want to try to convert it into a drug that will cost them a couple of $1 billion. So the first thing they do is they try to replicate the original findings. And when they do that, they regularly find huge error rates. Up to 80% of the time, the original work is wrong. So we must capitalize on this. And what I've been suggesting for quite a few years now is an Office of Science Review, where we've got to fix the quality assurance problem. It's not an easy problem because when it's convenient, the science institutions will agree there is a problem with peer review, but when it's inconvenient, they will say peer review is fine, and they do all these other things in addition to peer review. But I've been proposing an Office of Science Review which would be set up to test, check and replicate work. Initially, we were only worried about agriculture. We're not worried too much about climate science because in order to convince politicians to fund an Office of Science Review, it's best for it to be a little bit less contentious, so no climate change, no vaccinations. But for agriculture, most people love farmers, they know food is important, we think this is the way forward. Now ultimately, climate science and Great Barrier Reef science would have to be included, and we are certainly interested in the effect of agriculture on the Great Barrier Reef. Now, of course, the biggest problem is how do you stop an organisation like this being captured by the guys it's supposed to audit? And we've suggested that it operates within the Auditor General's department because they have, rather than the Department of Science, because they have some understanding of the independence and they have, even though they have no scientific expertise. So the question is, how do you stop the Office of Science Review being captured by those institutions? We've got to stop the groupthink because ultimately it's groupthink that's got us into the problems we have at the moment, and we've got to get the scientists out of the possible bubble that they're in. So one of the ways to stop the Office of Science Review being captured, and we've been doing quite a bit of work on this, is we need involved in this office scientists who've been on the wrong side of the peer review / bully / let me say a scientific mafia that often develops. So, for example, in Australia, there's a very famous fellow called Barry Marshall who ended up winning a Nobel Prize. And it was for discovering that stomach ulcers are caused by bacteria in the stomach. Now, up to the 1980s, when he made this discovery, all the stomach people said, no, the acidity of the stomach is far too great to allow any bacteria to grow in there. And this guy, Barry Marshall, has got to be completely crazy suggesting this. And they pilloried him, and he was... they really did the wrong thing with him. But ultimately, he was proven to be right. And he won the Nobel Prize for that. And so he understands what it's like to be on the wrong side of the peer group, a bit like many of us here. But on the other hand, he's been rehabilitated by the peer group and is now a very well-respected scientist. Now, he's probably an extreme example, but there are many examples of scientists who have been on the wrong side of the peer group and been proven to be right. And these are exactly the sort of people we need in our Office of Science Review to audit this science. But anyway, to cut a long story short, the Great Barrier Reef is doing absolutely fantastic at the moment. It's never been better. It'll probably be a little bit worse next year because, you know, there might be a cyclone which will knock over a bit of coral and you'll hear all the bad news stories, but it will come back. But what I am concentrating on at the moment is not just pointing out the bad science. We can do that with great ease, but it's working out systems where we can improve the quality assurance. And I do believe that we should all be, a large number of us should be working on similar things. And I think I'll leave it at that, and hopefully you were able to hear what I said.
Thanks. Thanks a lot, Peter. I mean, there was the applause. I don't know whether I could hear it, and I think some people will now, they got the hint that they will suggest you for the next Nobel Prize, I guess. Okay. Okay, wir haben ein bisschen Zeit, um ein paar Fragen zu beantworten. Fragen zu stellen und zu beantworten. Sie stellen die Frage und ich werde sie ihm dann, damit er sie hört, kurz dann übersetzen. Also, wer hat da hinten? 1, 2. Damit es auch alle hören, ja. Wenn Sie auf Englisch gleich reden.
Auf Englisch. Thank you for that interesting talk. May I ask a question back to the corals? You showed that graph showing the relationship between calcification and sea surface temperature. Can you explain in brief what is the relationship between calcification of the corals and coral death?
Well, the coral calcification is called growth rate, so it's not related to the death at all. You know, a cyclone will kill the coral, but the calcification rate is how fast these things grow. So there really isn't a relationship at all. But there's no doubt that the corals should be growing faster. They're already probably growing 10% faster than they were about a decade ago. About a century ago, I should say.
You mentioned that we need some kind of institute for good science, like EIKE, for example. The question is, how do we manage that this will be the institute that sets the standard? I mean, we need something like God. But in Germany, we say the fish always smells badly from the head. And this head is not only politics, it's certain organizations and pressure groups. Once we had a minister who said those who are elected don't have the power and those who have the power are not elected. So I think what we need is freedom, simply. And we have to stop this promotion of fake news.
I think there's nothing to be added there. And gut, da drüben noch. Fangen wir hier an, es ist praktischer erstmal nochmal kurz. Ja.
Hello, thank you very much for your interesting speech. I have a simple question. When I saw the title of your speech on the program, I expected something about the disaster of the Great Barrier Reef. And I understand now that there's no disaster. That's not clear.
That's absolutely right. There is no disaster whatsoever. The reef is in absolutely fabulous shape. It's always been in fabulous state. There is nowhere on Earth that is less affected by humans than the Great Barrier Reef. On the northern half of the Great Barrier Reef, which is, you know, about 1,000 kilometers long, the total population on the coast is less than 1,000 people, right? There is almost zero fishing pressure. There is no agriculture in the northern part of the Great Barrier Reef. It's that remote. Apart from perhaps somewhere in Antarctica, there is nowhere more pristine and beautiful than the Great Barrier Reef. So it's quite incredible that we've been able to convince everybody in Europe and everybody in America and everybody around the whole world and in most parts of Australia that it's almost dead. But of course it's underwater and these science institutions have a lot of power.
Okay. Kurz, yeah?
Peter, just for understanding, what is the mechanism of killing the corals by the great storms?
Oh, yeah, okay, I should have explained that. So what happens is that a big storm produces waves and the waves just smash the coral. So a lot of the coral is it's like plates, like a plate like this, and it just gets smashed by the waves. And they are by far the biggest destroyer of coral. So they can probably remove about 95% of the corals in about 12 hours, and it will take about a decade for that to recover. And it's been going on since forever. There's no increase in the cyclone intensity on this coast.
Ja, eine Frage stellt sich auf Deutsch, bitte die Übersetzer tätig zu werden. Es geht um die Wissenschaft. Peter, wie ist das? Haben wir eine globale Wissenschaft mit Qualitätsproblemen oder haben wir eine westliche Wissenschaft mit Qualitätsproblemen? Und ist die australische Wissenschaft Teil der westlichen Wissenschaft? Punkt.
Okay, so the question is, okay, we have a crisis, we have problems with science, so is it a global issue or is it just a Western issue? And if it's a Western issue, is Australia part of it?
I think it is a global issue because all the quality assurance systems in public science are the same everywhere. It may be not quite as bad in India. I suspect they don't have the groupthink there. Of course, science that's used in industry is very, very reliable because there's a financial imperative. It's only this public good science where there's a problem. Australia is as bad as anywhere. However, we are having quite significant success convincing some of the political parties on the right, centre-right, that the scientific institutions are unreliable. So this Office of Science Review has been taken up by the third party in Australia. It's sort of like the country party. Their main concern about it isn't that it's not needed, it's just that how can we set this up so that it doesn't get taken over by the bad guys. So in some regards, Australia, I think, may be at the forefront of trying to implement quality assurance systems. But to be frank, we're not quite sure how to do that in a way that the scientific institutions don't get hold of it and then corrupt it in the same way as they've corrupted almost all the other institutions.
I have one question regarding the charts you showed on the Great Barrier Reef. If I remember correctly, there were two minima on the state, the substance of the Great Barrier Reef, 2010 and 2015. But if I remember correctly, I haven't seen such minima in the many years before. Is that true? And if it's true, why is that so? Thank you.
That's right. Essentially, what happened was that the period around 2009 to about 2011, there was a couple of really major cyclones which were mostly responsible for that. And it wasn't that they were particularly intense, though they were intense. It was the route that most cyclones will have a route that will kill an area of coral, probably 100 kilometers across by maybe 50 kilometers, right? It's a lot of coral, but Cyclone Hamish in 2010, I think it was, it travelled about 1,000 kilometres down the Great Barrier Reef. So it killed an area of coral 1,000 kilometres by 50 to 100 kilometres. So that was a lot of coral, right? Just simply by virtue of its route. Now, there was certainly another major death event around 2016. That was partly bleaching. There's no doubt about that. But there was also another major cyclone. I think it was Cyclone Debbie, Hurricane Debbie. it's just the luck of the draw how these things go up and down. Though there's also no doubt that some of this data, it's got a fairly large uncertainty band to it. So, whether those dips are quite as big as they appear, who knows? And whether some of the flat bits in previous years might be hiding a real dip. So there's that needs to be considered as well.
I was just wondering, is this working? Yeah. I was just wondering whether the Australian tourism industry has any role to play in this whole debate, because they must be very unhappy when all the alarmists are telling the rest of the world the Barrier Reef is just about dead, no reason for visiting the place.
Well, you're absolutely right. The Australian tourist industry is absolutely ropeable at this. That and it's incredible actually that all these tourists, they go out to the reef and they say, wow, it's really good. We were surprised. We thought the whole thing would be dead. And of course it's not. So they are very cross with some of the scientific institutions about what they're doing and the UNESCO listing and all these sorts of things. But apparently there is an upside to it, because there's a whole bunch of tourists who are going to the Great Barrier Reef as last chance, because this is the last chance that they'll get to see the reef before it's dead. So they go out there before it's dead. So I guess there's swings and roundabouts. But you're right. The tourist industry are not happy. The agricultural industries are not happy. North Queenslanders are not happy with what's going on, and they're not happy with the scientific institutions, their unreliability and their untrustworthiness. And that's why there's been quite a stir in North Queensland to really get these scientific institutions back into line and doing reliable science again.
In der grünen Politik ist ja das CO2 der repräsentative Parameter. Und dort wird, wenn ich das richtig verstanden habe, so argumentiert, das CO2 macht das Meereswasser saurer und die Folge davon ist, dass zu wenig Carbonat hergestellt wird. Und wenn zu wenig Carbonat hergestellt wird, dann werden Korallen oder auch Schalentiere untergehen und vernichtet. Habe ich das richtig verstanden? Das ist ja eine sehr simple Erklärung, aber die kommt ja bei der ganzen Welt anscheinend an, weil es ja wieder so einen bestätigenden Charakter hat, dass das CO2 also der wichtige Parameter ist, und es ist ja auch leicht verständlich und jeder kann das schnell nachplappern, wenn ich es mal so sage.
Also, the question was the famous acidity, that the CO2 is evil for everything, and how in regard this affects the corals.
Right, so the acidity, well, the ocean pH problem, it's actually the only threat to the Great Barrier Reef that I think has any significant...
Peter, and also the calcification, also the issue of calcification, yes.
That's right. So the idea is that the calcification should drop as the ocean pH falls due to carbon dioxide. And there's certainly some experiments which indicate that some corals do slow their growth rate, their calcification rate. There's a lot of others that show it doesn't. And in fact, the main studies, so we can actually look at calcification rates over the last 300 to 400 years. You take a large coral, you drill a hole in the coral, and you can look at the calcification rate, because corals have yearly growth bands the same as tree rings do, or similar to tree rings do. And if you look at that data and you correct the errors that the Australian Institute of Marine Science made in their sampling, you can see that there has been no reduction in calcification rate. In fact, there's probably an increase in calcification rate over the last few hundred years. But nevertheless, some of the experiments do seem to show, at least in aquariums and even out on the ocean where they do some of these experiments, maybe that is a concern. But it's one of these areas where I think a lot more work needs to be done and a lot more checking and replicating needs to be done. But whereas the temperature increase and the effect of farmings is without doubt not a problem, or at least, you know, a couple of degrees is not a problem, the calcification one, I have to accept there may be a problem there.
Well, I have heard that during El Nino times, the sea level at the Great Barrier Reef sinks, and that is supposed to be a problem. Can you explain, say something about that?
Well, yes, you're quite right that in an El Nino, the sea level drops by about 30 centimeters, right? And in fact, a lot of the coral that died in the 2016 bleaching event, which was an El Nino year, it was actually killed by a drop in the sea level. So a lot of these corals come right up to the surface. And if you drop the sea level at low tide by 30 centimeters, they come out of the water and that kills them. So there's no doubt that some of the coral was actually killed by the El Nino. But remember, the coral goes down to 50 meters. So a 0.3 meter fall in sea level is neither here nor there. Though interestingly, and the previous speaker was talking about the Holocene climatic optimum. During the Holocene climatic optimum, the sea level on the Great Barrier Reef was about 1 meter higher than it is today. So over the last 5,000 years, it's dropped by a meter, and that's killed about 30% of the coral on the Great Barrier Reef. So if the sea level increases by a meter, we will see an explosion of coral on the dead reef flats which were killed by the sea level fall since the Holocene climatic optimum. So that's one of these ironic facts that they go on about how sea level rise is bad for the Great Barrier Reef. In fact, it would be marvellous for the Great Barrier Reef because all these dead reef flats would come alive again.
Okay, so we are a little bit short of time now, so we need also shorter answers from Professor Ritt. Okay, the next one.
Sorry.
A quick question. I was intrigued by the notion of an OSR, and to avoid institutional capture, have you considered maybe an open source approach and that allows maximum transparency?
Yeah, I think that's dead right. The other thing which we're looking at is whether we can set it up so that there's an industry sponsor. So, for example, if the sugarcane industry thinks that some of the work on pesticides is wrong, they have to put up, say, $1 million to help fund the replication. And if they put up some money for it and the government puts up another $1 million, then the sugarcane industry has some say on who's going to be doing those replication tests. So that's the other way it could be done.
Hi, Peter. This is Heinz. Just one question about the pH. Where does the pH stand in the Great Barrier Reef?
Good question. In fact, it fluctuates by about 0.4 to 0.5 pH units overnight, right? Maybe the pH has dropped by 0.1 unit in the last 100 years, maybe, right? I'm not sure it really has, but that's what they say. But between the day and the night, due to the respiration cycle that happens on the reef, there's a 0.4 change. And this is one of the reasons why maybe this ocean pH thing just isn't a problem, because the reefs actually deal with massive pH swings every day.
Peter, thanks a lot for your answer. Thanks for the crowd for this really exciting question. And I must say, we should talk a bit more about this part, because the acidity is still the ongoing thing, even if it's not dying now, it will die soon. So in this regard, thanks a lot for your presentation.
Thank you very much. Yep.
And we hope to have you our next conference in life, whatever. Maybe we have to find a different island where we all move to. And so thanks to your folks, your colleagues in Australia, and see you sometime soon. Thanks, Peter.
Right. Thank you. Bye.